Hello, Year 10s. Hope you're well. We're going to continue to talk about equations of lines today. We're going to specifically look at parallel and perpendicular lines. If we were in lesson today, you would be doing this as an investigation, and this is the investigation that you would do, but we're not in school right now, so I'm going to try to do the investigation for you. I'm going to try to talk quickly, but also very specifically so that this video does not go on forever. So let's get started. As you can see on this page here, there are 6 lines altogether, 3 on one graph and 3 on the other. Now, hopefully that you can see that these 3 lines on each graph are parallel to each other. So it also says the lines in the graphs are parallel to each other. We need to find the equations of the lines, and then we need to look at what do we notice. So I'm going to start with the lines on the left. So hopefully you remember from last week how to find the equation of a line from a diagram. So first you're going to want to find 2 points that are on the line. And you're going to want to go and calculate the gradient. So 2 and 2. So the gradient of this line is 2 divided by 2, which is 1. And it crosses at -2. So this line would be y is equal to x minus 2. And then I can do the same thing on the line above that. So there's 2 points there, and I've got 2 and 2, so the gradient must be 1 again. So this line would be y is equal to x, and then it crosses right here at 0, so I'm just going to write x plus 0. And then I've got this other line here, and I can draw my triangle, 1 and 1, so the gradient must be 1, and it crosses here at 2. So this line is going to be y is equal to x plus 2. Now, do you notice anything in all of this, in this particular question? Normally, I would leave you to look at this question for quite a while before you actually figure it out. Maybe you already know. And this is an x, and this is an x, and this is an x. And what's actually missing from each of these is this is 1x, 1x, and 1x. And do you know anything about this green number 1? What does that tell you about the equation of a line? Well, hopefully you're thinking y is equal to mx plus c. And on all of these lines that we just found, they all have the exact same gradient. That sounds interesting. Let's try the lines on the other side and see what happens. So let's go over here. I've got this point and this point, 2 and 1. So the gradient is 2 divided by 1, which is 2. It crosses here at -3. So this line is y is equal to 2x minus 3. If I go to the next line, here's a nice point. Here's another one. 2 and 1. Oh, the gradient must be the same as well. So y is equal to 2x, and it crosses here at 1. And lastly, let's try this point. There's 2 points there, 2, 1, and it crosses at 4. Y is equal to 2x plus 4. Oh, do you notice anything over here? We've got 2x, 2x, 2x. So on all of these ones over here, the gradient is 2. And on all of these ones over here, the gradient was 1. Can you make any kind of guesses about gradients of parallel lines? If you haven't, the next slide is definitely going to tell you exactly what's going on. Okay, lots of information here, not really much that you need to know though. So we've got a bunch of parallel lines there, 4 red parallel lines. You can see that they never, ever, ever meet. They all have the exact same space between them. Even if they carried on forever, they would never, ever cross. The bit that's in the bottom rectangle is actually the most important part. If you have your exercise book at home, I would really like you to write this down and maybe highlight it or put a nice box around it. What we want to get is that parallel lines have the same gradient but completely different y-intercepts. So parallel lines have the exact same gradient. So 2 lines are parallel if they have the same gradient. Okay, it would be a really good idea to press pause right now and write that down. Alright, so hopefully you just finished writing down that parallel lines have the same gradient. So this question says, what is the gradient of a line that is parallel to y is equal to x plus 2? So the gradient of this one is 1. So the gradient that's parallel would also be 1. So I've written down m is equal to 1 for the gradient is 1. For question 2, we've got y is equal to 5x plus 2. So the gradient that's parallel would be 5. For question 3, it gets slightly fancier. Y is equal to minus 7x plus 6. The gradient that is parallel would be minus 7. Now for the last question, it's going to get really fancy, and I'm going to go quickly, otherwise this video is going to end up being 45 minutes long. So we've got minus 9x plus 6y is equal to 1. Well, in order for us to find the gradient, the equation has to look like y equals mx plus c. Minus 9x plus 6y equals 1 does not look like y equals mx plus c. So the first thing that I'm going to do is I'm going to add 9x to both sides. When I do that, I end up with 6y is equal to 9x plus 1. That looks a lot more like y equals mx plus c, but it's not perfect yet. Now I have to divide both sides by 6. All right, and when I do that, I end up with y is equal to, I actually don't like the way I've done that at all, so I'm going to redo that. Instead of dividing it like that, I'm going to have to make sure I divide every single thing by 6. So I've divided 6y by 6. I'm going to do 9 divided by 6, which I can just write as 9 over 6 and 1 over 6. And there we go, that's pretty much it. The gradient would be 9 over 6. But we can also make that look a little bit nicer and simplify that to be 3/2. Now, if you really want to, you can also write it as a fraction. I wouldn't be super upset about that. So the answer to question 4 is 3/2. All right, I've got a few more examples of parallel lines and move on to perpendicular. All right, a very common exam question. Write down the equation of a line which is parallel to y is equal to 3x minus 4. So hopefully you remember that if it's parallel, it has the same gradient. So y is equal to 3x, and then you can put any number that you want after this. You can put plus 5. That's an acceptable answer. You could put 3x minus 202. It doesn't really matter. Whichever answer you want, as long as you've got 3x in there. If you really want to be fancy, you could even have y is equal to 6 plus 3x if you felt like writing it in a different order for whatever reason. All right, and that's it. All right, this next question looks kind of fancy, but it's really not. Write down the equation of a line which is parallel to, again, 3x minus 4. So we're looking for a gradient of 3, but it also has to pass through the point 0, 8. So we know it's definitely going to be y is equal to 3x. But this one has a bit of a rule about the y-intercept. So if I think really quickly about a grid, and I think about the point 0, 8, it goes 0 across and 8 up. So where do you think the y-intercept is going to be? Hopefully you're thinking it's going to be at 8, and it is. So y is equal to 3x plus 8. All right, perpendicular lines are definitely a little bit more complicated, and you kind of just have to trust me on these things. So we're going to talk about it, and if it doesn't go super well, don't worry, we can continue practicing it for the rest of the week. It's not really that big of a deal. So we're going to look at the questions on the left graph, and it says the lines in both graphs are perpendicular to each other. Find the equations of the lines. What do you notice? All right, so I'll start here. I've got this point, and I've got this point, and I can join them up. 3 and 1, so this gradient is 3, and it crosses here at minus 2. So this line is y is equal to 3x minus 2. And I can do the same thing with the other line. This looks like a nice point, and so does this. So this line is going downwards, so I've got 1 and 3. So the gradient is going to be minus 1/3. And it also crosses the y-intercept, or y-axis at minus 1. So this equation is y is equal to 3x. No, it's not. Hang on. This one has an equation of y is equal to minus 1/3 x minus 1. All right, so the top line has a gradient of 3, and the bottom line has a gradient of minus 1/3. Now I'm going to be completely honest with you. If you know what's going on already, brilliant. If you don't, I would not expect you to guess this all by yourself. So perpendicular lines, when they meet at 90 degrees, they have a really cool thing about their gradients. And if I try to multiply their gradients together, 3 from the top equation times by minus 1/3, well, I can pretend that this is just 3 over 1, and when I multiply them, I get minus 3 over 3, which is minus 1. When you multiply the gradients of perpendicular lines together, you get minus 1. What these are called negative, or hang on, let's backtrack there. Perpendicular lines have gradients which are called negative reciprocals. And what that means is, here's my first fraction, my first gradient, which was 3 over 1. And then what I need to do to get from that gradient to the negative reciprocal is I flip the 1 from the bottom to the top of the fraction, and it becomes this one over here. And I flip the 3 from the top of the fraction to the bottom, and it goes down here. And then I multiply everything by minus 1. Now, I promise you, perpendicular gradients are definitely way more complicated than parallel gradients, but we'll get there eventually. Let's try some questions on this before I end up going on forever. Again, similar to hopefully what you did for the parallel lines, if you have a book that you're writing in, it would be really good for you to write down about perpendicular lines. So these perpendicular lines here, they meet at 90 degrees, and if you multiply the gradients of perpendicular lines, you will always get minus 1. So maybe this gradient was, I'm not going to try to make up gradients, I think that would be a bad idea, but if you multiply the gradients of perpendicular lines, you're always going to get minus 1. All right, let's try some examples. All right, so similar to the parallel lines we did, what is the gradient of a line perpendicular to y is equal to 9x plus 7? Well, this gradient is 9. So the gradient which is perpendicular, which we can draw by drawing a little right angle because they meet at right angles, is going to be 1 over 9 with a minus sign in front of it. So I flipped it upside down and times it by minus 1. All right, hopefully that makes sense. Let's try the next one. So this gradient is 3, and the gradient that's perpendicular is going to be minus 1/3. All right, question 7, it says y is equal to minus 6x plus 1. So the gradient here is minus 6, and the gradient that's perpendicular is going to be 1/6. So when I multiply the minus 6 by negative 1, it goes back to just being normal old 6. All right, now this last question is definitely a tricky question. So first thing we have to do is we have to rearrange it. So we've got minus 8x minus 3y is equal to 2. So I can start by adding 8x to both sides. I have minus 3y is equal to 8x plus 2. Now I've got to divide absolutely everything by minus 3, and I get y is equal to minus 8/3 x minus 2/3. Hopefully from here you can see that the gradient is everything in front of the x, so minus 8/3. So let's write that down. The gradient of this line is minus 8/3. So the gradient that's perpendicular is, flip the fraction around, 3/8, and times it by minus 1. Well, negative times by negative brings us back to positive. All right, that is the general things for today. We'll try one exam question about perpendicular lines, and then I'm definitely going to stop talking. All right, write down the equation of any line that's perpendicular to y is equal to 1/2 x minus 7. So the gradient of this line is 1/2. So the gradient that is perpendicular is going to be, flip it upside down, times it by minus 1. So that's just minus 2. So I'm looking for y is equal to minus 2x plus any number I want. So plus 9, that would be acceptable. Or y is equal to minus 2x minus 452. Whatever number you'd like at the end, as long as you've got y is equal to minus 2x in the question. All right, hopefully this didn't go on too long, and hopefully some of that made sense. We will continue to practice this later in the week. All right, have a good day.